Plug in the value you're approaching, right? Cosine of pi over 2 is what? 0. So that's 0. And then what is tan of pi over 2, Mr. Gary? It is undefined, which really means 1 over 0, as you are well aware, which implies 0 over 0 and a frowny face. So now what? What's step 2? While you look at your paper, it's on the previous one. Well, we have to factor or simplify and be factored, correct? That's what we're going to do. Limit as x approaches pi over 2. I've got cosine x, and what is tangent? Sine over cosine. And we talked about this before. That's one of the 2 things you have to for sure remember for trigonometry. What is sine of x? Sine of x when x approaches pi over 2? 1.
Wait, how is cosine x times tan x 0?
No, cosine x is 0. Tan x is 1 over 0. So I get 0 over 0, and I don't know what I got.
Oh, wait, I get it.
Ah. All right, we're going to try the third one there. Good luck, it's a trap.
It says
0 over 0.
All right, Hillman.
Oh, well, when you look at it and you plug into the bottom one, it's something with a 0 next.
Well, what is the top? 0, so that's 0 over 0.
Yeah.
Frowning face. All right, some of you at this point might be wondering, why is it 0 over 0 every time? Why is that a big deal? The answer is, that's the whole second chapter, 0 over 0. Every last one of these 0 over 0. So that's why we're focused on 0 over 0. More on that later. So, what do I do? Factor. Limit. As x approaches 0. How can I factor the top? You got a sign. There's a sign in both of them. There's 2 terms. It's a binomial, so therefore I got to pull out something that's the same for both, or it's got to be different for squares, that sort of thing. The bottom line is I pull a sine x out. That's going to give me a 2 plus x all over x. Unfortunately, can I factor this? You did this. I assume that's a no. All right, no. I can't factor this. So now I'm back in frowny face land. What am I left with? The answer is there are 2 identities that AP Central requires you to memorize. Later this chapter, we'll sort of prove it. We'll sort of prove it by picking numbers closer and closer and saying, oh, well, it's obviously this. In chapter 5, we'll really prove it. It's still a long ways away. Okay? What are the 2 you have to memorize? Here they are. The limit as x approaches 0 of sine x over x is equal to 1. The limit as x approaches 0 of 1 minus cosine x over x is 0. Now, if I was going to tell the truth is it's almost always the one on the left, because once you see something that kind of looks like this, the whole thing usually goes to 0. So they generally don't use this identity, so it's almost always that one. So now that I know that, how would I do this? Question 2. Good. Stand in the way. By the way, they're down there. They're written on paper. They're in the paper. On paper. All right, how do I do this now? Who did I do this problem? I forgot. Helmet still? All right, helmet.
Well, I was just wondering how the 2 plus x changed.
So we're going to do the limit of sine x over x times x. Sorry, that was wrong. 2 plus x. Right? If you want to, you can put parentheses like this as x approaches 0.
And then that one turns into 1.
The first thing's 1, and then 2 plus x as x approaches 0 is 2. So this becomes
3.
Let's try it again. 1 times 2 is?
Not quite sure.
Not quite sure. Okay, I'm gonna put down a 2 just for fun. Who knew?
Not me.
That's fair. That's fair.
How did we get 1 and 2?
Okay. Well, the limit as x approaches 0, sine x over x, according to this identity, is 1. When I plug in 0 for this one, taking its limit, it becomes 2 plus 0, which is in fact 2. So it becomes 2.
Do we have to have those brackets on that?
No. In fact, you don't have to have these brackets at all. I mean, the limit would assume that these two are together. It wouldn't be a big deal. I try to be clear. You don't have to. You're allowed to follow whatever mathematical rules are allowed. You just got to be really clear. You can't have if you don't have parentheses here, it would go sideways. Right? Because you got to be multiplied in the middle. Okay. All right, that in mind, anybody try? I already did it. Let's try it again. I already did that one for you. So how about x approaches 0? Try that one out because that's a weird rule. And it's going to test whether or not you paid attention in trigonometry. You're just looking at me.
No, it's because we got 4. Oh, yeah. My guess is sine 2. I guess it's sine. I think he's trying to get us to
Yeah.
Well, we could factor the top and bottom, and if you remember your half-thing like anything I told you didn't have to memorize, we could do that right now. Or we can use good old-fashioned algebra 1. Which would you like to do? Algebra 1, okay. Tell me the front row said if the bottom was 4x, this would be identity on top, right? Because those would be the same. That's correct. How do I make the bottom 4x? Multiply by 2. Multiply the bottom by 2, then I have to multiply the top by 2, don't I? So then I get the limit as x approaches 0 of 2, parentheses, sine 4x over 4x.
But then the 2 is still going to the 4x.
That's fine, it's outside. So what's the limit at this? 1. That's 2. That gives me 2. Done.
Use mathematical identities? I don't know, I put the 4 in front of the sign. And then I'm
You're not allowed to do
sine
that.
x over
Okay,
x.
so listen carefully. So here's what you're solving. That is going to work, by the way, about 80% of the time, depending on the problem set up. But you know and I know, you're not allowed to pull that 4 out in front.
Well, let's see, I didn't know that. I tried to do the
Okay, but you do know that because you spent a year in trig where you realize you're not allowed to just throw the 4 out in front.
Right.
But we did go over that. You spent some time with that. And here's the bad news for you. If you pull it off on the AP test, they will stop on that step, say this is wrong, and take away your point. Unlike the test you took last year, which is pretty much answer, not answer, who cares about the work. The calc people are they really look at your work. They really go, this is an illegal step. Even if they know what you mean to do, and it's right, they still take away your point. Yeah. 4 halves from the inside the side?
So then I have 4 halves times sin x over x.
No, you can't take out 4 halves.
Yeah, that's what I mean.
Oh, what is this? What's the limit as x approaches 0? What is this identity? See previous worksheet. See previous identity. Right? It's sine x over x essentially. Since you're approaching 0, you can make multiples the same thing. I had hand up in this note and I told you last where it was.
I have the same question.
Same question. You're good? You're just rubbing your hand.
Oh, yeah.
No idea. We're talking about limits. That's got to be fun for you. All right, that's all yours. Go. Oh, that's my friend.